Seeing the Waves, the story of CRO, cathode ray oscilloscope. How many times we have stood by the beach and wondered at the sea waves, roaring, rising, falling, lashing the shore, and then withdraw, again and again. In our school, we learn that the sounds we hear are also waves, and the electricity we use is also a wave. But we have not seen the sound waves and electricity waves. 100 years ago, a few scientists wanted to actually see the waveforms of sound and waveform of electrical currents, just like we see the sea waves. It will improve our understanding and help us to solve a number of complex problems, they thought. The steady direct current could be measured using a galvanometer. But measuring a current that varies with time was a big challenge in the 19th century scientific world. Different techniques like oscillograms, oscillographs, and mirror galvanometers were invented, but they could be used only up to 100 Hz, which was too small. Our story today traces the story of their quest that will eventually invent the cathode ray oscilloscope and continue to explain the principle of operation of the oscilloscope and how it is used. In 1869, a German scientist, Johann Hittorf, placed two battery terminals, also called as electrodes, inside a glass tube and removed all the air. He then applied a high voltage and discovered that the glass opposite the negative electrode, also called as cathode, started glowing. This was later named as cathode rays, since the rays were coming from the negative terminal or cathode. During the late 1800s, Thomas Alva Edison and his team were working very hard to produce a working model of an electric bulb that can be used at homes. In 1883, while experimenting, Edison added a small plate inside the glass bulb and connected it to the positive terminal of a battery. When the bulb was switched on, after a short time, electric current started flowing in the plate. How did the current flow in the air from the filament of the bulb to the plate? This was something new to Edison, and he published his findings. This was later called as the Edison effect. The year was 1885, and the world did not know about the electron, which is a negatively charged particle inside. Edison did not pursue this new finding further, as he was involved in improving the electric bulb only at that point in time. The release of electrons from a hot metal surface is now known as thermionic emission. The study was later taken up by Professor J.J. Thomson of Cambridge University, London, who got the credit for discovering the electrons. Professor J.J. Thomson explained that electrons were actually leaving the hot filament of the electric bulb and were attracted to the positively charged plate. Positive charges always attract the negative charges, and this explained the Edison effect or thermionic emission. John Ambrose Fleming, who was an engineer and physicist, invented the first electronic tube or diode valve based on J.J. Thomson's discovery and the Edison effect. Diode was coined from the words two electrodes. The diode, in simple terms, is an electronic switch. It has a negatively charged cathode that emits electrons when it is heated and a positively charged anode that receives the electrons emitted from the cathode. The diode was the starting point of the growth of electronics and was initially used in Morse code communication and radio communications. In 1906, an American inventor, Lee De Forest, invented the triode by introducing an additional plate called as control grid. In this tube, there are 3 electrodes, and so it was called as a triode. In addition to cathode and anode, the triode now had the control grid, which could control the flow of electrons across the cathode and anode. The triode was used in sound amplifiers and also in radio frequency communications. This triode forms the basis of the modern day cathode ray oscilloscope. The first working model of the oscilloscope was invented by Ferdinand Braun in 1897 using phosphor-coated glass. This was also called as the Braun tube. Many inventors improved this model, and in 1931 the first commercial oscilloscope was released by General Radio.